All right, let's do a few specific examples where we find some arc length and area. So again, with anytime we're going to do area, and it's probably not a bad idea with arc length as well, we should look at a graph. So in this one, we're talking about square root function. And then we're talking about y equals x squared, but it's been compressed a lot, so it's a really flat version. So I think it's going to give us some kind of funny wedge like this. And we don't care about what's happening on the left-hand side because the square root graph, although it looks like I drew it continuing, it shouldn't. It dead ends right at the origin. So when you get directions that say region bounded by, that's telling you the pieces that make up the perimeter. So the entire perimeter of the region needs to be made up by a square root of x and an x squared over 8. And it also is implying, bounded by is implying that I'm looking for a finite area. So I would not be looking out here because there's infinite area. I would not be looking anywhere on the left because there's nothing bounded by the two curves. It has to be this little piece in the middle. So I can look at that and I can actually get a pretty good start right off the bat. I can say, okay, that's the square root of x minus an x squared over 8 that I want to integrate. So always the bigger curve, which is the square root curve in this case, the bigger y value minus the smaller y value. So the height of a rectangle is going to be given by that. The width of a rectangle is a dx. I know I need to start at 0, but I actually have to do a little scratch work to figure out where to stop. So I need to know what this point of intersection is. If I want to find a point of intersection, I'm going to assume that my x's and y's both have to be the same at that point. So if y is the same, I can just set the two formulas equal. And I'm going to multiply by 8. I guess I didn't have to multiply by 8 first, but I think I still like it. And then I'm going to square both sides to get rid of that square root. So I have a 64x equals 64, equals x to the 4th, which means x to the 4th minus 64x equals 0, which means either x equals 0, which we already knew, or x cubed equals 64, which means that x is 4. 4 times 4 is 16, and 16 times 4 is 64. So, back up to this, and again, this is why really important that you draw a picture every single time and think about this. You're often going to have to figure out on your own which one is the bigger y value. In fact, always you have to figure that out on your own. The points of intersection, you have to figure out whether or not they cross at other points so that you're catching two different areas. Okay, so to calculate this, whenever possible, practice your integration. This is an x to the 1/2. So the antiderivative is going to be an x to the 3/2 multiplied by 2/3. And then this guy, the 1/8, is just going to carry through. It's going to become an x cubed, and then we're going to divide by 3. So this is actually 24. And we're going to evaluate from 0 to 4. And plugging in 0 doesn't give us anything, but plugging in 4 gives us 2/3. Okay, so this 3/2 power means square root and then cubed. So the square root of 4 is 2. 2 cubed is 8. And then 1/24 of 4 cubed, which is back to that 64 that we had. Okay, so these often you can do by hand. And in general, you should be trying to practice that. So I have, again, the exception would be if you're only asked to set it up, great. That's something that might happen on a test if I want to give you something really messy and just look for what you can do without a calculator. Here I can simplify, at least by taking out a 4. I can do more than that, but I'm going to start with that. So when I divide by 4, I get 16 over 6. I can cut that in half. I get 3. And what was I doing? Half 8. So minus 8/3, which is 8/3. Okay, so the area trapped between the two is 8/3. I'm going to switch colors and we'll work on perimeter. The perimeter is really an arc length. So we just want to add up the length of the two curves between 0 and 4. So I'm going to start with the square root function. And I'm going to say, okay, I need to integrate from, reverting back to my generic situation, 0 to 4. For this one, I know that dy dx, we got to go the other way. So that was an x to the 1/2. So we're going to get 1/2 x to the negative 1/2. And this one, we'll just call it y prime for space saving. The 2 is going to drop down in front, and so we're going to get an x over 4, a 2x over 8, which is an x over 4. So for the square root one, when we go to find the arc length, it's going to be a 1 plus 1 over 2 root x squared. And then you can keep these in one integral or split them up. When we go to find the area or the length of the quadratic, it's going to be 0 to 4 square root of 1 plus x over 4 squared dx. And this again becomes a technology problem in general. What do we have here? The second one actually is probably simple enough that you don't necessarily, let me think about that. Nope, it's an x squared. I lied. I think they both are messy enough that I probably want technology. With the x squared, you could try trig substitution. I will try and be really clear on any sort of test, whether I want you to do these by hand or just set them up, or if it's something that you have a calculator on, if that's an option. So, I was not preemptive in this. Let me go ahead and type it in really quickly. And you can use this just to check and make sure you're good at entering these things into technology. Plus almost done. Okay. Oh! Almost done, except I typed something in wrong clearly. X 0 to 4, so 1. I think I got it. Sorry guys, should have planned this. I always do that. Okay, it's not giving me an error, but it is taking its dear sweet time thinking. Okay, well possibly I broke it. So I'm just going to call this one instead of making you sit and wait. Oh, there it went. I was about to give up. Okay, 6.37 is what I'm getting. And you should be able to do a little bit of a reasonableness check. One way to do that here would be to say, okay, this point, what do we know at that point? The y-coordinate's 4, I'm sorry, the x-coordinate's 4 and the y-coordinate's 2. So we could say if this is side length 4 and this is side length 2, then the hypotenuse would have length square root of 16 plus 4, so square root of 20, which should be a little bigger than 4. 4.4-ish. So what we're talking about is taking this length and adding it onto this length. Ooh, actually, I think that's a little suspicious. You might want to recheck my this work. I'm again not going to make you sit through that again because I'm slow. But I would say that each of those sections should be longer than the 4.5-ish. So I think that 6.37 is a little low. So very smart to do a reasonable check. Mine says that my calculator skills on this one sucked. I'm not going to make you wait for me to fix them. But I am very skeptical about my 6.37. Okay, thanks for watching.